Hello everyone, welcome to Indian School of Physics. So guys, this is NLM tutorial 2, and here also we are going to discuss the beauty of choosing the right frame of reference. And again, I have taken another problem from Pathfinder, and I'll be covering some key concepts and their applications from Pathfinder in the upcoming series. So you can take this problem. Let's discuss the problem statement first. So it is given that there is a light. You can go through this. Okay, I'll just directly brief you about this problem part. Here it is given that this block, it is connected to a string, and this end of the string is pulled with a constant velocity of v naught in uniform gravity, and it is given at theta equal to theta naught. Here at theta equal to theta naught, it is leaving the contact. So the very first thing which will come in our mind, that here tension is going to be T, and whereas this point is moving with constant velocity. In the previous video also, we have seen the advantage of any point moving with constant velocity, that we don't have to deal with the pseudo forces. So in this situation also, since length of the string is constant, so I can choose a frame from here, and you can see that this block should be moving in a circular path. This is the key concept here, and let's see how exactly we can apply in this situation. So the very first thing is the constraint relation. Directly we can say, if length of the string is not changing, v1 cos theta will be equal to v0 sin theta, and which is going to give us v1 is equal to v0 tan theta to us. And another part, based on the information given to us in the problem, at theta equal to theta naught, block is leaving the contact. So here T sine theta naught will be equal to mg if normal reaction here becomes 0, and that is the instant when this particle is going to leave the contact. So once we have these two equations, we can proceed to the third one. I hope you are realizing the similarity between this problem and the last problem. It's almost similar type of approach, exactly same, I'll say. Only thing is, the application wise FB device situation is changing a bit, otherwise it is same. So with respect to point P, block B will be moving in a circular path. So I'm observing this entire motion of this block from B, and I can say this is the circular path. So very first thing which we can do is, the relative velocity along this line is going to be 0, which we have already used in this case. And now another situation here we can take is, there is a tension T and there is this mg force. Normal reaction has become 0 at the instant when we have when this block is leaving the contact. So you can see the net velocity of this point is going to be along the circular path with respect to point P. So I'm calling this as V relative. So you can see this velocity is V1, this velocity is V0, this angle is theta naught. So V1 is sine theta naught plus this is going to be theta. So V0 cos theta naught. That will become the V relative, and that will be along the circle. So if I substitute the value of V1 here and simplify, I am going to get this value as V0 by cos theta after simplifying. Now I can write net force towards the center, so tension T and component of mg in this direction. So component of T minus, and since this is theta, this angle is theta, this is 90 minus theta. So mg cos 90 minus theta, this will become sin theta. So T minus mg sin theta, here you can see, and that is equal to mv relative whole square by L. Circular path equation we are applying. And when we simplify this, tension we have calculated at the time of leaving, you can see it was T is equal to mg by sin theta naught. So the same value I'm substituting here. Tension is mg by sin theta naught minus mg sin theta naught. You can substitute the value of V relative. Once you simplify, you will be getting V0 value in terms of theta and GL. So that will come out. If you simplify this, this will become cos square theta, cos to the power 4 theta. So this V0 is square. I should have written this V0 square. All right, so v naught square is equal to gl cos to the power 4 theta naught by sine theta naught, and this is going to be the final answer for us. So I hope you are realizing how beautiful this concept is. So what I will do is, in the next video I am going to give you a challenge which I have framed based on these two concepts. I have slightly made it tricky so that you have a crystal clear idea that how we have to resolve component, in which direction we have to apply circular motion equations. So all these things will be clear to you. Do check it out. And guys, this is about compete, and as you know, it's a very unique feature of an academy platform where you can play, you can battle. I'll call it battle instead of playing. So both of the parties will be getting certain section, a certain numbers of problems from PCM, and based on the winner you'll be getting some rating points. So it's a very fantastic way of learning, I'll say. And there's another one about those who are participating for a state CET. So there is some discount going on. You can use it, or if you want to connect with me on an academy live classes, you can use my code Nitin sir. So that's it guys in this video, and do check it out. The next problem, it will be a challenging one, and I'm sure many of you will be able to solve this. So that's it in this video. Thank you.